Okay, guys, so we are talking about the sum and difference formulas today. The reason that we want to learn about these is because they allow us to find the exact answer to problems that we normally cannot find the exact answer to. For example, if I wanted to find the sine of 75 degrees, I can't find that exact answer because it's not something that's a 30, a 60, a 45. It's not one of those that's exact. If I type it into my calculator, if I go under degrees for my mode, and I type in sine of 75, that's not an exact answer. Even if I try to math frac it, it's not going to be able to do it. It's not an exact answer. So what we're going to do is we're going to use these formulas that we have. So this is saying that if I have the sine of two angles added together, it's going to be equal to the sine of the first, cosine of the second, plus the cosine of the first and the sine of the second. Completely new formulas that we've never used. But what we have to do is break 75 down into some angles that we know. The angles we can evaluate are 30 degrees, 45 degrees, and 60 degrees. So how can I rewrite 75 using some combination of those? Yeah, go ahead, Natalia. Right. So I can just write it like this. So here's my A, here's my B. I'm just going to use my formula. So here's my formula right here. I'm going to have to do the sine of 30, the cosine of 45, plus the cosine of 30 times the sine of 45. To find the sine of 30, I've got a couple of ways I can do it. I can use my unit circle. I'm not going to get that out though, so I'm going to use a triangle. This is 30. This is 1, radical 3, and 2. The sine is going to be opposite over hypotenuse, so that's 1/2. My cosine of 45, I need a 45 degree angle. 45 is 1 radical 2. The cosine is going to be adjacent over hypotenuse, so that's radical 2 over 2. I need the cosine of 30. The cosine of 30 is radical 3 over 2. And the sine of 45 is radical 2 over 2. So now simplifying this, I'm multiplying these. So 1 times radical 2 is radical 2. 2 times 2 is 4. Plus radical 3 times radical 2 is radical 6. 2 times 2 is 4. So this would be the exact answer to that problem. Okay? So if I want to check that answer, I can just put it into my calculator and do the radical 2 plus radical 6, enter, and then divide that by 4, and there's what the decimal approximation is. Do you see how that's the same exact thing we got earlier? But this is an exact answer, and this is just a decimal approximation. Okay? Questions on that? Yes, Abby. You will. This year, you're lucky. You get the formulas. Next year, in pre-calc, they're going to expect you to memorize them. Okay? So, I will give you a sheet on the day of the quiz that will have all of these plus all the other ones. So you just have to be able to apply them. All right, let's turn the page now. Let's do an example problem. Okay, we're going to do this, well, let's just move it over here. I want to do, instead of these that they have, there's a reasoning behind me changing these all the time, but I want to do the tangent of negative 75. It's just going to help you more with your homework to do this one rather than these that they have. All right, so to do the tangent of negative 75, I have to think of two numbers using 45, 30, and 60. How can I get negative 75? What can we do? We can use negatives of these as well. All right, so I can make this negative 30 plus negative 45. Now, I also could have made it the tangent of negative 30 minus 45. Now look at the difference here. In this problem, A is negative 30, B is negative 45, and I would use the sum formula. In this problem, though, A is negative 30, B is positive 45, and I would have to use the difference formula. But do you see how they're the same thing? It's just that we would be using different formulas. So we can choose either one. I'll just go with this one. All right. So we're going to have to be looking back at our formulas. So to do this, I'm going to have to do, I'm doing the sum. So the sum right here is tan A plus tan B over 1 minus tan A times tan B. So I'm doing the tangent of negative 30, and then it's always plus the tangent of negative 45, and then on the bottom it's 1 minus the tangent of negative 30 and the tangent of negative 45. Now, if I have negative angles, all that means is that instead of going in the positive direction, I go in the negative direction, like this. So here would be 30 degrees, this would be 1, this would be radical 3, this would be 2. For negative 45, I would go in this direction. And so this would be 1, this would be 1, this would be radical 2. But I also have to check whether things are positive or negative. This is positive, but this is negative. The radius is always positive. This is positive, this is negative. Radius is always positive. Okay, so now to do this, I'm going to have to do the tangent of negative 30. So that's here. I would have to do opposite over adjacent. So that's negative radical 3 over 3 plus the tangent of negative 45. Well, that's going to be opposite over adjacent, and so that's going to be negative 1 over 1 minus the tangent of negative 30 is going to be negative 1 over radical 3, which is going to be negative radical 3 over 3, which would make this plus radical 3 over 3. And the tangent of negative 45 is going to be opposite over adjacent, so that's negative 1. So now this is back to a negative again. This is 3 over 3, sorry. All right, we're not going to need this space, so I'm just going to rewrite this down here to show you how to simplify it. It almost looks like our answer should be 1 or negative 1, but it's not at all. What we want to do first is we want to get rid of this common denominator. So I'm going to multiply the top by 3 and the bottom by 3. When I distribute that through, I'm going to get negative 3. I'm going to get negative radical 3 rather, because the 3's would cancel on the first term. When I go to the second term, I get minus 3. And see how that got rid of my fraction there in the numerator? In the denominator, I'm going to multiply that, get 3. Multiply this, the 3's cancel, and I get minus radical 3. It is still not exactly alike, so it's not going to be 1 or negative 1. Does anybody remember how we get rid of a radical in the denominator? Jake? Good. So I have to multiply by the conjugate of the denominator. And now I have to multiply this out. So I'm going to have negative 3 radical 3, minus 3, minus 9, minus 3 radical 3, all over 9, plus 3 radical 3, minus 3 radical 3, minus 3. So now simplifying, on the top I'm going to have negative 12 minus 6 radical 3. On the bottom, these two cancel, so I'm just going to have 9 minus 3, which is 6. Now I want to factor a 6 out of the numerator, and I'm left with negative 2 minus radical 3 all over 6. And now the 6's cancel. And that's what we get for our answer. If I were a person taking a quiz over this, I would now check it. I'd go back and see what is the tangent of negative 75, get that answer, and I want to see if this is the same thing. And it is, thank goodness. Because if it's not, you got to go back and find your mistake, and it's usually just a positive or a negative error. Okay, we're not actually going to do another one of these, but I want to talk about how you would go about setting this up. So to set this up, I would change this into degrees first. So to change this into degrees, you can think, what's another name for pi? What is it, guys? So I can now just type this in as 35 times 180 divided by 12. We get 525 degrees. All right, now this would be pretty tough to do. If I subtract 360, it's really an equivalent problem. So I'm going to just take away 360 to come up with an equivalent problem, because you know how that's just taking away one revolution. It's not going to change it in any way. So I'm going to do 525 minus 360, and that gives me 165. Now, we don't have to just use 30, 45, and 60, because we could also use 150, 135, 120. Do you see what I'm doing, thinking of the second quadrant? Are there any combinations there? Like, can I combine any of these numbers with any of those numbers and get 165? Which ones could we combine? Yeah, so I could write this as the cosine of 30 plus 135. And the reason I want to do that is because I know the sine and cosine of 30, and I know the sine and cosine of 135. And so then we could just write the formula, but we're not actually going to do that one. Okay, so number 6. We're going to draw pictures here to figure out what these values should be. So drawing this, we've got angle A. So they're telling us the sine of angle A is negative 4/5, and that angle A is in between pi and 3 pi over 2. Which quadrant is that going to put that in? Third, good. So I'm going to draw a picture in the third quadrant. I've got sine, which is opposite over hypotenuse. So this is negative 4, this is 5. What's the missing side going to be? 3. And is it positive or negative? So negative 3. All right, so we've got this triangle figured out. Now we have to figure out our other triangle. It says B has to be in between 0 and pi over 2. Which quadrant is that going to put us in? First quadrant. This is adjacent over hypotenuse, so adjacent over hypotenuse. Do we know the missing side here? And this is for triangle B. So now see if you can just write out the formula first. So this formula goes cosine A, cosine B, plus sine A, sine B. I'm just writing the formula for you. So now I just look at my triangles. Cosine A is negative 3/5. Cosine B is 5/13. Plus sine A is negative 4/5. And sine B is 12/13. And so now I'm just going to simplify this. I've got negative 15 over 65, and then plus negative 48 over 65, and that's going to be negative 63 over 65. Questions on that? All right. We're going to do a couple more here, just with simplifying. So let's go ahead and just do number 9. So on number 9, this is our A, this is our B. Look at your formula. We're doing the sum of signs, which is right here. Okay. So I'm just going to apply the formula. So I'm going to have sine X I mean. So sine X, cosine pi over 2. And then it's going to be plus cosine X, sine pi over 2. So we need to think, what is the cosine of pi over 2 right here? Well, this point is 0, 1. So what is the cosine of pi over 2 going to be? Just 0, right? It's the x value. So we're going to have sine x times 0 plus, and then what's the sine of pi over 2? 1. So it's going to be 1 times cosine x. And so 0 times anything is just 0, so my answer would just be cosine x. So if I had to plug in a value for x, instead of using this, I could just do cosine x. All right, any questions? It's kind of difficult, but once you sit down and just do it on your own, a couple of them, it'll start really making a lot of sense to you. I meant to do this tangent, but I guess you'll be okay. Let me just talk real quick about, like, if you ended up with something like this. Like, let's just say you end up with 3/5 plus 5/4 over 1 plus 2/3. If you ended up with something like that, like you wouldn't for this problem, but I'm just saying if you did, would you know how to simplify that based on what we've talked about? What's the common denominator? 60 would be the common denominator. So I'm going to multiply the top by 60 and the bottom by 60. How did you get that common denominator of 60? Just multiply the denominators, right? So now I'm going to distribute this through. So what is 60 divided by 5? 12 times 3 is... And then what is 60 divided by 4? 15 times 5, 75. And then here, 60 times 1 is 60. 60 divided by 3 is 20, times 2 is 40. So this answer for this would be 101 over 100. So that's the quickest way to simplify when you have a complex fraction. A lot of people are tempted to get a common denominator here, do this answer divided by this, which makes you do this answer times the reciprocal of that. That's totally fine, but I'm telling you, it's a lot longer doing it that way than it is that way. Right? What's that? Well, just because I can't add, you're not going to hold that against me, are you? Thank you. All right, any other questions? Okay, so you guys, you have your homework up there, page 523, 1, 2, 3 through 19, every other odd. It only ends up being like 7 problems because these take a long time to do. So ignore what's on your assignment sheet, just do these instead.